In this video, we're going to talk about JavaScript functions or functions in JavaScript. So far, everything that we've been creating, there have been certain cases where you notice that you're doing certain things that are a bit more repetitive in the way you write your code. And we can be able to basically reduce that sort of repetition with functions. So functions help us reduce that. But at first, I would like us to just understand the anatomy of a function and how a function looks like. So I like you to think of a function as a self-contained block of code. I'll just write here as self-contained. It's a self-contained block of code that performs a specific task, and I'd like you to just make sure that you underline this one here. It performs a specific task. This is super important because the whole purpose of a function is to reduce repetition and at the same time ensure reusability. So whatever you write in a function should be something that you can also reuse anywhere in your program if you wanted to, and you're going to see a sense of how you can do that. So it is a self-contained block of code that performs a specific task. Now I'd like us to just start with the simple syntax of a function and how a function is written. To create a function in JavaScript, you just use the function keyword. Then you follow this by the name of the function. So let's say a function it's called greet. Then you have a set of parentheses, and then after this you can go ahead and have your curly braces. And in here is where you write what your function is supposed to do. In this case, our function is only going to console.log a statement that says hello. It should be a string here, says hello. Then let's say I would like someone like Zen. So you say hello Zen. Then here now once you've created the function like that, then you can now call the function. Now this is super important because if we leave it like this and we go ahead and run our code, I'll just call node. I call this file functions.pure.js. Once you run that, you see we don't get any output in the terminal. The reason for that is because functions, before they execute anything that you've given them, you have to call them. That this is the super important part. You have to call a function for it to execute what you want it to do. It can be as complex as it can be, but if you don't call it, it will not execute. So how you call a function is you take the name of the function, in this case great, and you just have the set of parentheses right there. This is simply how you call a function. And let me just add a semicolon here. Now, if we run our code with that, it should be able to give us an output. And you can see here we have the output that says hello Jane. This is super important for functions. Now, to just understand what you're seeing here, a function, some of the terms that you'll also experience a lot as you're moving forward. The first term is what we refer to as an identifier. So an identifier is the name you call the function by, right? In this case, greet is an identifier, right? So an identifier is the name that you call a function by. I hope you're taking some notes. The other term that is going to come up in function is body, or in this case, a function body. So a function body is any code that you write that is within in between these curly braces here. So anything between these curly braces, and this is typically what runs when you invoke the function. So invoking a function is basically like calling a function. So that is what we refer to as the body of a function. Then so there are a few things that we need to look at here. The program that you've written so far pretty clean, but an even better way you can write it, right? So I'd like you to just ask yourself, for example, what if you didn't want to say greetings to Zen, right? What if you just wanted to be able to pass in any name that you wanted to? So to do that, this is where we bring about a concept called parameters. Parameters simply refers to let's simply refer to them as sort of variable names that you pass in between these parentheses here. So for example, I'll pass in name, right? So actually, let's start with this. This is the best way for us to start. I'm going to declare a variable here. I'll call it name, and I'll go ahead and give the name to be, in this case, let's just go with the exam that we have. Then, when we are saying console.log, this is one of the ways that so we can pass in using you can be able to pass in the name that we have. That is the name gen in here. And to pass in the name Jen, okay, I'm going to just use what we refer to as string literals. So string literals is you have a set of backticks, then I can pass in the first statement hello, then it's going to be followed by the name of this person that in this case the variable. So how you do that is I have a dollar sign, then I have a set of curly braces, and then I can pass in the variable name that is here. So in this case, if we run our code, this is what it's going to look like. It's going to say, hello, Jen, right? So of course, if I go ahead and change this to maybe Paul, and then I run it again, it will say, hello, Paul. Right? So now that you've done this, instead of doing it like this, right? Because this is again an extra sort of sort of kind of complexity that you're adding to your code. We can simply replace all this by passing in name in here. Then I can get rid of this line of code there. So this name that we've passed in between this set of parentheses, we usually refer to this as parameters, right? So parameters are the input that you give to your function, or rather what your function expects during function definition. This is super important. Here we're defining our function. What we pass in here is what we refer to as parameters. I'd like you to note that during function definition. Then now, if we run our code right now, you just run it. You see, it says hello undefined. The reason we're getting hello undefined is because we've passed in the parameter name, but we haven't given it a value. So you do this when you're calling your function. So when you're calling your function, in between this set of parentheses, you pass in the actual name. So the actual name, let's say the name was my name here. So I'll pass in Bonaventure, and if this is what you pass in. So in this case, we refer to this as an to this as an argument. This is a parameter. This is an argument. So not parameter is used during function definition. Then arguments are used during, or rather we refer to this as arguments during function calls. So when you're invoking our function, and remember arguments are basically actual values that the parameters usually refer to. Now, if we run our code, you'll see it says hello Bonaventure instead of hello undefined as it was doing before. So this is super important when you're doing function definition, or rather when you're working with functions. Now, as you're working with functions here, there's one thing that you should also note as well. Note that this function is only just console.logging a statement, right? Like we said, functions are self-contained pieces of code, basically, or blocks of code that perform a specific task. So any specific task that this function is going to perform, you're the one to define it. For example, you can write a function that, let's say, prints an even number, right? Or rather, it checks if a certain number is an even number, like that. And you can do that as a function. So its specific task is going to be checking if a number is even, something like that. So you can do that. It can be more than one line of code. Just as a note, because I noticed that a few people do struggle with what that means. So let's go ahead and introduce something else here. Right now, we're just doing console.log, right? We're just doing console.log, and this is because this is basically prints the inputs right direct in the console.log is going to give the inputs in the terminal in the console of a browser in case you connect this to like some HTML code. But there's another thing that you can also do whenever you're working with functions, and it's something that you have to really note here. And it's what we refer to as hoisting, right? Whenever we declare functions, we declare them as we have, and then as you can see, we call them later on, then they give us the output that we want. But at the same time, if I remove this and I decide to call them right before I write the function, one thing I want you to note here is that this is what we refer to as synchronous code. So synchronous code is basically what you are writing. What that means is that our program executes line by line. So basically, it will not execute line 5 before it executes line 3. It follows that chronological order. So that is what we mean by it being synchronous. And in this case, we are calling a function before we even define that function. And that is what we refer to as the concept let me just give you an output first to see what you mean. So you see, when I call the function, right, it still gives me an output as much as I'm calling this function before I even define it, right? What this means is that, or rather in the concept of hoisting basically refers to lifting the declarations of, in this case, the function to the top of their scope, right? And in that case, it makes it safer for us to call the functions from anywhere in that scope. Now, the term, I've used the term scope here, and you're wondering what it means. In the next video, we're going to talk deeper about scopes, but basically what a scope means is, for example, when I define this function here, right? When I define this function, if I declare a variable inside of this function, that variable is only accessible within this function. It cannot be accessed outside. But if I declare a function, a variable outside of a function somewhere here, if I declare a variable here, this variable is going to be accessible throughout the function. But again, don't worry about that. We're going to cover it simply in the next video. But I'd like you to know hoisting. What hoisting does is that it lifts the declaration, in this case of this function, to the top of its scope so that it's safe to call it from anywhere in that scope. In this case, because we're declaring this function like this, that means that its scope is, let's refer to it as sort of global, so it can be accessed anywhere. So even if it's after or before, that's why we're able to call it like that. Right? So this is important. But now, as we talk about hoisting, there are certain cases whereby hoisting does not apply to functions, right? I hope I'm not losing you here. So what that means is that we've declared our function like this, but there's usually what we refer to as, and I'll just have this as a function, rather as a comment, we refer to this as function expressions. So a function expression is not hoisted. Remember, hoisting occurs here when you're doing this sort of function declarations. But a function expression looks like this, right? You write a function. This function does not have a name, but you store the function, in this case, the output of that function, to a variable. It looks like this. So let's say I have const, then I declare a variable. Let's say a variable say goodbye. Let's call it like this, say goodbye. Then of course, this is again how you declare a normal variable. Then you create, but now it is a function, right? So you have a function, then you have a set of parentheses. Note that this function does not have a name. That is super important. Then you have your body. Inside your body here, you can console.log a simple statement, and I'll just have this statement say something like goodbye. In this case, this is what we refer to as a function expression, right? A function expression like this, if we go ahead and call it down here, so I'll just call say goodbye like this. Note that say goodbye does not have parameters, so I don't have to pass in anything in here. So I call it, and let's run our code. You'll notice that it prints out the statement goodbye. Of course, we expect it to do that, right? But let me try to call it. Let me try to call it. I'll just remove it from here, and I'm going to control X, and I'll call it before declaration, right? So what I'm trying to do here is I'm trying to see whether it has the same behavior as this function definition that we have up here. So if I run my code now, you see that the code runs into an error. And the error is we get a reference error, and it says it cannot access say goodbye before initialization. That is as clear as it gets here. It's basically telling us that we cannot be able to call a function before it is declared, which means which means that this type of a function, in this case a function expression, these ones are not hoisted. So I'll just write here not hoisted, right? But this kinds of function definitions that we have, or rather we refer to this as, let me just write it simply here, we refer to this as function declarations. So I'll just write here function declaration. So a function declaration is this one. This is a function declaration. This is a function expression. Difference between the two is that a function declaration gets hoisted, but a function expression does not get hoisted. The other thing is that a function expression, of course, you write your function, you state in a variable, but when you're doing a function declaration, you basically just write function, then you put your name in there. I mean, you can visually see the difference between the two. So that is super important to note here. Now, when you're writing function expressions like this one, they can be anonymous, or you can also give them names, right? In our case here, this is a named expression, what we have here. So this is not anonymous. This is basically an anonymous expression. sorry for that confusion there. But there's a named expression. So what a named expression looks like is you have an almost similar function. Let me just copy this and paste it here. But I'll change this to, I'll just call it hello. And in this case, what you do is you basically have your function, and I'll just call it, for example, hi. I'll call the function hi. So you give it a name. So what you mean by this is a named function expression. Named function expression. So this is named. I'll just add a D here. These are named because you can see we give it a name, but we still store it in a variable. But this one, this is an anonymous expression, so we don't do that. When you're working with named expressions like this one here, they can help us with what we refer to as stack traces and recursion. But those are sort of topics that we're going to talk about in a later video. They're not super important at the moment, but I'd like you to just take that into consideration. So this is the simplest way you can talk about functions, right? How you define a function, what a function expressions is. But there is more to functions than what you've just looked at here. There's what we refer to as, I'll just write as a comment, but we'll look at this in a separate video because they are kind of separate. So there's what we refer to as arrow functions, right? Arrow functions were introduced in ES6. ES6 is a newer version of JavaScript, but we're going to look at arrow functions in a separate video. For now, this is what functions do look like. I'll just get rid of this one for now, but note that we're going to look at them later on. What I'd like us to focus on for a moment here is focus on how we can expand functions, because so far what we've seen is the simple architecture of a function, and that is basically it. But we can be able to expand our functions if you'd like to. Now, what I'll do, I'll just comment all this out, and actually, I'll not comment out. I'll just get rid of the function call so that they don't print out anything. And I'd like us to create a function. Let's say a function that adds two numbers. So I'll just write here a comment. Function that adds two numbers. And I'd like for you to try. I mean, you can also just pause the video here and try it on your own. So let's do it. So you write function, of course. I just want to use the normal function. So write here function. Then let's call this function addition, like that. Then in this function called addition, we give it parameters, right? Let's say we want to add two numbers, right? That means we can give it two parameters. Not that what we've seen so far is giving one parameter, but we can give it two parameters. Let's say one is called num1, the second parameter is called num2, then you have our curly braces like that. Then here we can basically do the addition in our functions. Now this is going to introduce us to something else, but what I'd like us to do first, I'd like us to just declare another function here, and I'll call it not function but variable. I'll call it result, and I'll just give it num1 plus num2, right? This is the simple output that gets stored there, and then we just console.log the result, and we have a semicolon there. Then we're going to call the function. Then of course we pass in our arguments, and I'll just give it the two numbers. Let's say 23 and 90, and I'll save that, and then let me clear and run our program. So once we run it, you see it gives us 113, right? Which is the correct way. But this is how you get that you can expand your function. You can give it two parameters, you can give it two parameters as well, but don't give it too many parameters to the point whereby it is almost unmaintainable. Just be mindful about the number of parameters that you use here. So once you've written it like this, notice that what I mentioned earlier, we're using console.log. All this does is it prints out the output it prints the output to the terminal. There's one thing I'd like you to note about when you talk about the anatomy of a function as well. As far as rather more than what you've seen beyond the definitions and everything, and the fact that functions do a specific task and they're self-contained, the more important thing is that whenever you're writing functions, there is the life cycle of a function. Let's refer to it as that. The life cycle of a function basically is you declare a function, right? And then you give it the specific expressions or the functions that, or rather the work that the function is supposed to do, right? Then at the end of the day, the function has to give you a result, right? In this case, we are printing out the result directly. When you're dealing with functions, the function basically its life cycle ends once you print out the output like this. What that means is that you cannot reuse such a function, right? A function that once you call it, it basically prints its output directly. That its life cycle ends the moment it prints out the output. So it's basically sort of dead in quotes. And note that we mentioned that functions have to be reusable. We mentioned that in the beginning. Functions have to be reusable. So to ensure this reusability, we make sure that our functions do not print out the results directly. We make sure that they return the result. To return a result, it's pretty simple as well. Instead of using console.log, you use this keyword known as return instead of console.log. Then you tell it what you want it to return. In this case, I want it to return result like that. So now this is where another difference comes in. When I call it, you notice that we don't get any output in the console here. That is because, of course, we're not printing the output to the console. Now, to print the output to the console, we have to wrap the function call in a console.log. So I have to do console.log like that, and then you run it, and you can see now you get the output, right? So this does not, once you do it like this, it does not affect the life cycle of a function, because the function still retains that result. It's like it holds the result hostage somewhere, so that you can be able to call that result anytime that you want, right? This is important to note when it comes to the life cycle of a function. You make sure that you want to return, so that you can reuse the function later on when you want to. So to simplify this further, you can, instead of just printing out result, of course it's kind of direct that you can just return num1 plus num2 instead of just the variable like that. But I just leave it to you to be a bit more creative in terms of how you handle that. So super important to note that. When you talk about functions, there's also something that was introduced later on ES6 together with the arrow function, but I can just talk about it here. And that is the concept of default parameters. What default parameters means is not that the parameters that we have here, these are a bit more sort of dynamic in a way, because you have to basically pass them in yourself. But there are cases whereby you can pass in a default parameter. What that means is you have your parameter name, but you assign it a value direct. Like in this case, I just say num2 is 70. So what this means is that when I call my function, I don't have to give it two parameters. I'll just give it one. I call it and it gives me the output, right? But okay, if I want to override what you have in the beginning, I can just give it another value there. And if I run it, you see it gives us the result now with 56 instead of 70. But of course, we don't use default parameters as often, but it's important to note that default parameters do exist. The other thing to note about functions is when you're calling your functions, the arguments have to match the parameters. What that means is that if this has to be the value for num1, and this has to be the value for num2, it basically has to follow the same order during the function definition, in this case with your parameters, and during the function invocation or function calls in your arguments as well. Super important to note that. So for now, this is what all we're going to talk about as far as functions are concerned. I believe this video is long enough. There's still a lot more that we're going to talk about as far as functions are concerned. So tune in on the next one as well. But as a sort of as an assignment from this one, I'd like you to just go ahead and look at some of the programs that you've written before. For example, the programs in decision could be, for example, this program here. You can turn this program into a function, or rather convert it to a function. Any of the programs from before. Also, just try to do some other test of your own. Okay, cheers, and I'll see you on the next one.